Welcome to the first tech engineering update of 2026. And honestly, this year did not wait around. CES just wrapped up, and if you strip away the flashy demos, one thing is very clear: the way we build software and hardware is changing fast. This week alone, we saw NVIDIA redefine what AI even means. Intel finally delivered on a promise it's been making for years, and a research paper that could quietly change how large models are trained. I am Abhishek Saini, and this is your weekly engineering brief. Let's start with the biggest signal from CES NVIDIA. Jensen Huang didn't just announce a faster chip, he reframed the entire conversation. With the Rubin platform, NVIDIA is officially pushing into what they are calling physical AI. AI that understands space, motion, and real world constraints, not just text. Rubin succeeds Blackwell, but the more interesting part is what runs on top of it. NVIDIA introduced ElpMayo, an open source reasoning model family designed for robotics and autonomous systems. These models don't just detect objects, they reason about what can happen next in the physical world. For engineers, this is a real shift. We are moving from prompt engineering to spatial reasoning, from text pipelines to sensor pipelines. The future of AI isn't just in the cloud, it's embedded in machines. While Nvidia dominated data centers, Intel made its most important move in years. The Core Ultra Series 3 Panther Lake is here, and more importantly, it's built on Intel's 18A process node. This matters because 18A isn't a marketing fluff. It introduces backside power delivery, which separates power routing from signal routing on the chip. That single change reduces inference, heat, and wasted energy. Here's the practical impact for developers: local AI is finally realistic. Offline inference, private assistants, on device code generation. This is the return of serious computing on personal machines, not just thin clients for the cloud. Now let's talk about something quieter, but potentially just as important. DeepSeek published a new research paper introducing something called Manifold Constrained Hyperconnection, or MHC. This tackles a long standing problem in deep networks. How do you make models wider and more expressive without blowing up training? Their solution is elegant. They mathematically constrain how residual connections mix information, preserving stability while allowing much richer internal representations. No new model launch, no hype video, just a clean, efficient idea that could make future models smaller, cheaper, and faster. If you care about model architecture, this paper is absolutely worth your time. You can find the link to the paper in the video description. Now, while everyone else is fighting over cloud inference, Qualcomm is focused somewhere else entirely: the factory floor. They unveiled Dragonwing, a dedicated SoC architecture for industrial robots and humanoids. This isn't about chatbots. Dragonwing is built for real time perception, visual SLM, and path planning directly on the device. That means no cloud round trips, no latency surprises. For embedded and system engineers, this is a big deal. It means AI powered robots that actually scale in real environments like warehouses, factories, and logistic hubs. Physical AI is no longer experimental, it's operational. The final story isn't about the hardware or models, it's about culture. Industry analysts are calling January 2026 the start of the accountability phase of AI. The pilot era is over. Companies aren't asking, can we build this anymore? They're asking, can we trust it? That shifts the burden to platform, DevOps, and infra teams. In 2026, shipping AI isn't impressive anymore. Proving it is reliable is. So that's week 1 of 2026. AI is getting physical, hardware is reshaping software again, and accountability is becoming a core engineering skill. Which of these shifts do you think will hit your stack first? Edge AI, local inference, or AI governance? Let me know in the comments, and if you want a clear engineer first take on tech every week, subscribe. I'll see you in the next dispatch.